Hi, this is Brandon Baines in the Math Department at Lipscomb University. I'm here to talk with you today about x-intercepts and y-intercepts of linear functions. In this app, you'll learn the definition of an x-intercept and the definition of a y-intercept. You also learn how to find both of those values for linear functions. An x-intercept is an ordered pair in which the graph of a function crosses the x-axis. This is not a unique definition to linear functions. This is actually a definition for all functions. Any ordered pair that crosses the x-axis is called an x-intercept. X-intercepts will always have a y value of 0 because it is the ordered pair directly on the x-axis. The y-intercept is the ordered pair in which the graph of a function crosses the y-axis. And again, this definition is not unique to linear functions. It is actually a definition that is true for all functions. Y-intercepts will always have an x value of 0 because it's an ordered pair directly on the y-axis. When looking at a graph of a linear function or otherwise, since these terms are not unique to linear functions, and interested in finding the x-intercept, then we simply look at the x-axis and locate the point where the graph crosses the x-axis. And so we'll see here, it appears to be at 0.5, when x is 0.5, and the y value is 0. So you'll notice anytime you're on the x-axis, the vertical value or the y value is 0. For this reason, a lot of times we'll get loose with our language and say that the x-intercept is 0.5, but the x-intercept really is an ordered pair, and so that's why we would like to state it as 0.5, 0. To find the y-intercept, we'll simply go to the y-axis, and we will look for the point where the graph crosses the y-axis. It appears to be right here. This is a very thick line. This turns out to be the ordered pair 0, 1. That is, the y value is 1. And again, a lot of times we are loose with our language and say the y-intercept is 1. Technically, the y-intercept is an ordered pair. So we say 0, 1. We can use an XY table to identify the x and y intercepts. That will require that our XY table has those ordered pairs already computed. Remember that an XY table only shows a finite number of ordered pairs, and so it would be possible that we've constructed an XY table with no errors, but we just don't have those values shown. You can also use a graphing calculator to look at the XY table of a function, and that will show many more ordered pairs than what you normally would do by hand. Keeping in mind that the x-intercept will have a y value of 0, and keeping in mind that the y-intercept will have an x value of 0, then we're going to look at our XY table and we're going to locate the ordered pairs that have that form. That is, ordered pairs with y values of 0. Those will be our x-intercepts. And ordered pairs with x values equal to 0. Those will be our y-intercepts. So we look at this XY table here. We see that the ordered pair -1, 0 has a y value of 0, so that it will be our x-intercept. We see here that the ordered pair 0, 9 is on our XY table, so that will be our y-intercept. Well, since we knew this was a linear function, we actually knew the y-intercept already. You remember in out 2.1, we said that linear functions have the form f of x equals mx plus b. And if we go back and look at our function, our equation of our function, it is f of x equals 9x plus 9. 9 is our b, which we defined to be the y-intercept in app 2.1. We can also use equations to find the x-intercept and y-intercept respectively. We'll still use those two main ideas we've been using. That is that the x-intercept has a y value of 0. And so to find the x-intercept, we'll let y be 0 and we'll solve for x. To find the y-intercept, we're going to let x be 0. And again, we'll solve for y to find that y-intercept. With linear functions, the y-intercept is in the equation already, that f of x equals mx plus b, where b is the y-intercept. However, as we progress throughout this course, we'll start looking at nonlinear functions. And when we look at nonlinear functions, we will have to do some computing to find their intercepts. Let's take a look at an example. We have the function f of x equals 1/2 x minus 3. Since the x-intercept is an ordered pair with a y value of 0, we'll let the y value be 0. And so picking up here, we've let y be 0, and we have 0 equals 1/2 x minus 3. So now our task is just to find the x value that makes that equation true. We want to find the ordered pair solution to this equation. So first we'll maintain the equality and add 3 to both sides of the equation. That would result in 3 is equal to 1/2 x. And again, when solving an equation, we attempt to maintain equality. In fact, we have to, or else we've changed the problem. So whatever we do over here, we need to do over here on the left side of the equal sign. Multiplying by 2 would result in just x. And so if we multiply by 2 on both sides, we get 6 is equal to x. So then the x-intercept is the ordered pair 6, 0. The y-intercept is the ordered pair 0, -3. And we know that from the definition of a linear function, f of x is mx plus b, where b is the y-intercept.